everyone, George here, and we're back again with another missed class. I absolutely loathe missing classes, but I really don't have an option this week. I'm roped into doing something and there's no way out of it. But that being said, it doesn't mean I can't send you some videos and hopefully get you to learn something in the meantime. Today we're going to be focusing on things such as drawing lines, and that's going to become the basis for our entire Polygon class, because really all we're going to be doing is drawing lines. So make sure you have your project open from the last two videos that I submitted to you, and make sure you've finished everything inside of them, because we're going to be picking up right after that, and we're just going to go ahead and create our own new class. All right, so go ahead and into Java really quick. Now, before we create that new class, let's just talk about the functions we're going to be using, or methods. In this case, once again, we're working with the canvas object, and we're going to be calling, instead of the point one, we're going to be calling draw line. We provide the beginning of the line, the end of the line. We provide the beginning of the line here and the end of the line here. Now, unlike the paint object for dots or points, this one becomes a little bit more complicated. We can do things like specify the color. We also have a thing called the thickness of the line and several other parameters. So we can do much more now with a line than we could with a single point. Now, an important thing to know is that you might want to increase the width of the stroke that gets drawn to the screen. The reason for this is, by default, it's going to be 1 pixel, and it might be incredibly difficult to distinguish that line from anything else if it's so thin. So first of all, we're going to create a generic class that's going to let us draw an n-sided polygon. So let's create this object. Let's move this off to the side. Let's go over to Java now, click on a project, right-click, New Java Class. In our Java class, let's create a Polygon class. Our superclass is going to be Game Object. And that's pretty much it. So go ahead and hit OK. We're going to, of course, get some errors here because we haven't implemented anything yet. So why don't we go ahead and do that? I'm going to hit Alt-O or Control-Insert. We need to implement init, onUpdate, and onDraw. Hit OK for each of those. Now we need to add some variables to this object. So let's talk about these for a second. So now that we have our class, we need a position, obviously, for this. We need to know how many sides our polygon is going to have. We're going to need a series of points, and that's going to be an array of vector 2D objects. Each point is going to be what we iterate over to create our n-sided polygon. We have a paint object, and then we have a radius that we're going to work with. So getting started, let's create a protected vector 2D, or excuse me, vector 2 position. Let's create a protected integer value. Let's just do num sides. I'm going to set that by default to 3. Can't do number of sides equal to 2, really. Protected vector 2, and that's going to be an array of points that make up the object that we draw. A protected paint object. Alt-insert that, and a protected float radius object. Now, do understand the reason we're storing these points away is because we're going to continually call onDraw, and that's the only way we're going to be able to create something on the canvas. If we just draw this once and discard the points, we'll have to regenerate the points every single time. By creating the points once and then storing them away, we never have to worry about spending a lot of time creating those points and wasting computational time. So we do it once and we leave it there. Okay, so moving on. Next up, we're going to work with our constructor. Our constructor is going to take in all of these different parameters here, number of sides, the X and Y position, and then a radius for that value. We create our new paint object. We set up our information such as our colors and our stroke. We're going to add all of our different points in there, creating our new array. We're going to check to make sure our radius isn't too small, because if it's negative, it doesn't make any sense. We're going to check to make sure the number of sides is big enough, and if it's not, we'll set it equal to just 3. And then finally, we're going to store away our position. So instead, let's see, let's go to Alt-Insert, and let's go to Constructor, and we're going to pass in our, let's see, number of sides. We're going to pass in X and Y, which really can just be a vector 2, so let's do that. And we're going to pass in our radius. There we are. It's already gone ahead and set those up for us right there, but we do need to do a couple checks. First of all, with our radius, if radius is greater than, well, actually, if radius is less than or equal to 0.0f, we're going to go ahead and set radius equal to 1.0f. Just give it an actual value. Then we're going to do the same thing for number of sides. If number sides, num sides, is less than or equal to 2, then set num sides equal to 3, and then we'll store that value away. And then of course our position just ends up being the same position. The only other things we need to do now are set up our array and our paint object. So let's do paint. So paint is going to be equal to a new paint object. And next up is the array. So let's do points is going to be equal to a new vector2 array. And the size of that is going to be based upon the number of sides we have. So remember, if I'm creating an object, let's say I'm creating a quad, right, with 4 sides, that has 1 point, 2 points, 3 points, 4 points. However, what do I actually need to do to make this work? Well, if we designate these as 1, 2, 3, and 4, I have to draw a line here between 1 and 2, right? So that's 1 point, 2 points. Now I have to do 2 to 3. So that's 2 to 3. So you could do this a couple different ways. You could store 1 and 2, right? 1 and 2, and then you could store 2 and 3. And then what would we do next? Well, then we could store 3 and 4, right? And then we could store 4 and 1, right? Now remember that each one of these is actually a vector. So I'm actually storing a total of 1, 2, 3, 4, 5, 6, 7, 8 different points. Well, that's a lot of information to store. Since I know I'm working with a continuous object, since it's a polygon, I know that the previous point I'm dealing with is going to end up being the one I'm working with when I'm drawing it. So that is 2 is the same here, 3 is the same here, and 4 is the same here. And then 1 we come back on, right? So that's 1, 2, 3, 4 to draw this particular object. So we can do a little bit of a cheat here. Since we know that a polygon is going to be a continuous object, we can set the number of points equal to the number of sides that we have. That means if we have a 5-sided object, we end up with 5 points. We know that 1 is connected to 2, 2 to 3, 3 to 4, 4 to 5, and so forth, and 5 back to 1, which makes our life easy. So let's go ahead and put in num sides. So next up is the actual math that we calculate inside of the constructor. We're going to want to calculate an angle. And basically what we're doing is we're creating a circle of different segments. So for instance, if you say I want to create a circle that has 3 sides, well, our angle is going to be equal to 360 divided by 3. And we're going to iterate all the way around it. That's why we have a float value of 2.0 times math.pi, which is going to give us our 360 degrees or 2 pi radians. And then we divide that by the number of sides. And that is equal to the angle we have in between each one of those. So for instance, here we go, we've got a full circle, right? And then of course we've got 0 starting there. And what we want to do is split this up into a triangle, right? So how many degrees do we do that? Well, a triangle is equal to 3 sides, and then we're going to end up dividing 360 by that, which means that each one of these is 120 degrees. So we're going to end up going from here 120 degrees around, and then another 120 degrees around, and then we're back at the beginning at another 120 degrees. You connect those, and you end up with a triangle. And you can do the same thing for any particular object. So let's begin that part. And actually, you know what? Maybe we should put this in a separate function. So let's create one called protected void calculate points, actually. Let's do that. So the first thing we're going to do is find out our angle. So float angle is going to be equal to, and I want to typecast this as a float object because math.pi by itself is a double object. So we're going to do 2.0f times math.pi. We're going to divide that by the number of sides, num sides. Now actually, do I need to typecast that since I'm multiplying by a float? Yes, I do, because it upscales that to a double. So actually I want to get rid of the f there and let it be a double object. Now we're going to create a double, and I'm going to call this cumulative radians. And what this is going to equal are the number of times that we have gone through a loop or iteration. What do I mean by that? Well, we're going to create a for loop, and we're going to iterate over it over and over and over again. And with each iteration, we're going to figure out what our cumulative angle happens to be. Now, we could store this as an integer value and just multiply that initial delta angle value by it, or we can just continually add to the cumulative radians portion of this and increase what its size is. Doesn't matter to me, it's up to you, but we're going to go with this one for now. So now we're going to create our for loop. So let's do for int I is equal to 0, I is less than num sides, I plus plus. So we're going to go to points. I is going to be equal to a new vector 2. And what that's going to be composed of is a radius value times the math.cosine of our cumulative radius. So the cosine is going to return to us our x position. That is, the cosine is going to be a value between -1 and +1, and our radius is going to upscale that to whatever size it needs to be. However, the issue we have right now is the fact that this is going to be a double. We need to convert that over to a float at the moment. So let's go ahead to the next part and do a radius times, once again, a float value, math.sine, and let's put in cumulative radius there as well. Close that off and end it. That can go. All right, so we've got our vector calculated. Now we need to increment our cumulative radius. So cumulative radius plus equals angle. So with each iteration, we increase by the amount of angle that we've calculated here, and then we calculate our new point all the way up to the end. So under draw, we're not going to need an update class right now because we're not going to be updating anything. But if you wanted to, you might be able to do something like calculate points with an offset value, and that offset would be added to whatever this angle is so that you could slowly make it rotate if you wanted to. You could do some fun stuff like that. It's entirely up to you. We're going to leave it blank in this example so you can have some fun with your own particular stuff, because we're going to have a homework assignment where you're going to make your own game using your game engine that we're writing here. But anyway, let's go ahead to the draw class, or the draw method inside of our class. We get our canvas object. We're going to iterate over all the different points, see what's going on. Now, this is actually wrong. If you take a look at Android documentation, it says that this is the slowest way to create a for loop. The reason for this is because it continually does not know what this length is. If you happen to put inside the length before it, like an integer value, and then declare the length, it only does this once. Therefore, it will be faster than, well, it'll be as fast as if you use a smart for loop as opposed to this. But anyway, we're going to go ahead and add our position to it, and our position again, and we draw a line for each one. Now, we are going to do a little bit different from what you see here. We're going to have one additional draw line at the end, which is going to connect the last point to the first point. So what you see in my notes, which I'm going to provide on the website, works just fine. The example that I'm doing right now, though, is a tiny bit different, and that's just because I know that a polygon is going to be continuous. It's going to start at one place and end at the same place, so I can get away with changing the code up a little bit. So let's go ahead and create our for loop. So first, though, we need that integer value. Int length is going to be equal to our points.length. Now we can do int I is equal to 0, I is less than point is less than length, I plus plus. Now we're going to define two vectors. We're going to do a temp1 is going to be equal to vector2.add. We're going to add whatever our position was, which is where the user ends up clicking, to the point that we happen to have calculated at I. So why do we do this? Because if you don't do this, you're just going to end up with the same polygon points at the same place. They're all going to be around the origin. We need to offset them by some amount, and that amount is going to be wherever the user happened to click a button, press a button. Now in this case, I'm passing in what? That's a vector 2, and that's also supposed to be a vector 2. But I actually don't have a method in my vector class that handles this. So why don't we go ahead and create that really quick? So going back into vector, I'm going to create a static version of this method that makes my life a little bit easier. So let's do a public static vector2, and I'll do add. That's going to take in a vector2 or vector2 right hand side and a vector2 left hand side. This is just another way of doing vector math. Rather than needing a vector first, this way I can pass in two vectors and get a new vector out of it. We're going to return a new vector2, and what that's going to be is simply our right hand side dot x plus our left hand side dot x, and then our right hand side dot y plus our left hand side dot y. And now we just need to make this subtract, and we'll grab the same line of code and we'll put minuses instead of pluses. And there we go. Now we have these two implemented. Let's see why it's given us problems. Oh, it's never used. That's fine. So going back to our Polygon class, now this is going to make sense. Now we're going to figure out where the other point is. So temp2 is going to be equal to a vector2 object dot add, and once again it's the position and points I plus 1. Now what we have to be careful of is the fact that we have a certain length right here, okay? Now we're going plus 1, so we're going to actually exit outside of the number of points we have, which is going to cause an error. We only really want to go up to the length minus 1. We're going to handle connecting the last part of it outside of this loop. We need to finish drawing, so we'll do canvas.draw, and it's going to be draw line. Now we'll take in temp1.x, temp1.y, temp2.x, and temp2.y. And then finally our paint object. Now we haven't set our paint object up yet, which was back in our constructor, so we should do that now. So paint dot set color, and we're just going to set it to something. Let's do color.argb. I'm going to do floating values this time, so we'll do, how about we do green? So 0.0f, 1.0f, excuse me, 1.0f, 0.0f, 1.0f, and then 0.0f. Now let's change our width, so paint.set stroke width, and I'm going to set that to be 4.0f. Let's take a look here and see what's going on. This requires API level higher than what I have, so let's try a different one. We'll go with int instead. So we'll do 255. Red will just be 0. This will just be 1. And this one will just be a 0. And there we go. So apparently using floating point values is something you're only allowed to do later on in Android. Now we just need to do one last bit, and that is finish everything off. We're going to do that inside of draw. We need to copy this line, and we need to make sure we connect everything at the end. Why do we need to do this? Well, if we shift F5 everything, and we get something that I can draw with, remember we have 1, 2, 3, and 4 points. However, we're starting at the 0th point, and we're going all the way up to the end of it, right? However, our loop uses this point plus 1 in it. So if you go all the way up to the last point, which would be number 4, so 0, 1, 2, 3, this would be 3, and then we would go to a point that doesn't exist. So what we need to do is handle the case of, okay, we're 1 before the size of the entire thing, let's connect that back to the beginning, which is element number 0. All right? So jumping back in Android Studio, instead of this being I, and actually we need to, well, let's make this a little bit better, actually. Let's declare the vectors here. So we'll declare vector 2 and vector 1 right here. And we'll set them equal to that here. Temp1, since we reuse it over and over again. Temp2 there, and we'll get rid of this one and this one. All right, and instead of I, it's going to be length minus 1. and this will end up being the 0th element, the first one. And then we'll draw that last one once again. So now why don't we go into our game view now and actually make this populate some area. So we have our list of game objects that we create inside of our constructor, and we added our star field. So let's create our new polygon. So we'll do new polygon. Let's see what we need. So Control P. We need a vector 2 position. We need the number of sides. We need the radius. So we'll do a new vector 2 for our position. We'll also need the number of sides. Let's just say 5 for now. And then the radius we'll say is 20.0f, 20 pixels. And our new vector is going to be equal to, let's say the center of the screen for now. So we'll do a get screen width. That's an integer value. And we're going to divide that by 2.0f. And we're also going to do get screen height, which will divide by 2.0f as well. And that should put a polygon into our scene. Why don't we go ahead and run this and see what happens. Let's go to run our app. Let's go with pixel 25. Let's rotate our app. So as you can see here, nothing shows up, and I made a huge mistake. I forgot to actually call the method we created, hence why it's grayed out. So why don't we do that at the end of our constructor right there, and go ahead and try that again. So now that we've created our new polygon, the last thing we need to do is make sure that we add it to our game view. So let's go ahead and do that with a game objects. So the last thing we need to do now that we have gone ahead and created our polygon is add it to our game objects. So we can do this by doing game objects.add, and then let's just create object temp is equal to that, and then pass in temp. Okay, let's go ahead and see what happens when we run this. So hit run. Okay. So this is why we can't see it. I had accidentally left green at a value of 1. Let's set that equal to 255 and go ahead and run this. So now we can see right dead center is our little pentagon. So you can go ahead and do whatever you want to with this. We can go ahead and change the scale of it, the size of it. It's up to you to do whatever you want to, but that's how you can create pretty much any size polygon you want with it. Now, like I mentioned before, if we wanted to do something maybe a little bit of fun, we could, in our onUpdate method, continually increment by some amount the rotation that it's undergoing. So let's do that really quick. So let's just, to make this a little bit more interesting, do a protected float accumulated angle is equal to 0.0f. And we could have a speed value as well. I'm not going to worry about that at the moment. So accumulated angle. And what we want to do is get from that, let's see, let's say the speed is, I don't know, 3.0. Let's say accumulated angle is equal to plus equals, let's say it's, I don't know, dot pi divided by, I don't know, let's say a 20th of pi. And we'll multiply that guy by game view dot delta time. So delta time times that is how much we've incremented since our last update. And we're going to add that to it. So now all we need to do is use accumulated time over and over again inside of our calculate points. So instead of calculated points being called once, it's actually going to be called a lot of times. So we're going to do cosine plus accumulated angle. And this one also plus the accumulated angle. Whoops. Just that, please. Thank you. Now it's very small, so why don't we blow that up? But it is certainly rotating. So let's go back into game view and blow that up to maybe 60. And instead of rotating so slowly, let's go back into Polygon and increase our speed to, say, a tenth of pi, which should be much faster. And here you go. Now we have our rotating polygon continually going around and around and around, and who knows when it'll stop. All right, that's enough for this video. So now we've taken a moment and we've learned how to create our own Polygon class, and we've learned how to use drawing, and hopefully I've shown you a few different techniques for how you can use for loops and so forth to come up with some interesting game objects. I hope you enjoyed this video and you learned something new. Remember to go through this, implement everything, because this kind of stuff is going to help you out on your own game when we have homework next week. Thanks everyone. See you next time. So long. Goodbye.